rational? What's a rational number? Whoa, 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 whoa. That is exactly right, Wyatt. Wow. Purple. No green. Green? Green. Teal? These are the colors I have to choose from. I can add a color. What color? That's what that's supposed to be, but it turns out being more. How about that? No, it was, yeah. For what? Block. No, yesterday's was, power functions. Yeah, I have to print you one. This is notes, yes. Oh, I got it up here because I told him it was a quiz, but it wasn't. Delaney, will you pass that back too? I forgot to ask, did y'all have questions? It was pretty easy. You okay? How accurate do we have to do? Yeah, number 4. Number 4. Let's look at number 4 together, and then we'll come back to this. Oh. All right, Wyatt. Wyatt, where does a horizontal shrink or stretch go? On the X. Exactly right. Not just in front. I know, that's why I said that. Huh? Yeah. This is number 4. Isn't that which one you said? All right, so this should be even, right? Because even though it's negative, it's still an even exponent, and I'm a monomial. As long as I'm a monomial, if it's even or odd. Yes. Negative even. If the exponent is negative, okay, so I've got some monomial function, actually. This key asked for yesterday. What this? I like this pink. Don't like that. You don't, or you do? The fraction's gonna deal with shrinks or stretches of it. No, it would go. So if I had 1/2 x to the negative 3, I could write it like that. All right, so back to this one. This is my 5/2x to the negative 4, right? So my sketch of this one, what's the domain? The range is what? 0 to infinity. X-intercept. Number 4. None. There is no x-intercept. This graph is never going to cross the x-intercept. On mine, it's thanks, Delaney. Woo, there you go. How about y-intercept? None. That's right. How about increasing intervals? And this is what you said you had trouble with. So as I move left to right, this is one of my Cal kids said this the other day, and it made a lot of sense to me, and I've never really thought about it. She said before she starts, Slade, stop looking at people's tests. Oh. As I look at this graph, right, she said she goes left to right, and she puts little arrows on it because she gets confused on increasing, decreasing, and she does this. I'm going up, 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 I'm going down, I'm going down. Oops, I put that wrong way. I'm going down, I'm going down. And she labels her graph that way so that whenever she comes in, she goes, okay, arrows going up or increasing, arrows going down or decreasing. So increasing on this would be 0, right? And decreasing would be, that's right. How about symmetry? We already talked about this. Just a second. Even symmetry, and I can tell that one of two ways. We know that this equation is 5 over 2x to the negative 4. I can tell because this is an even number, right, and it's a monomial function. The other way I can tell is looking at the graph. It's symmetric about what? The y-axis. That's exactly right. Discontinuities. Infinite because there's an asymptote, yes? All right. In behavior. And this was kind of a little bit of new stuff. All right, let's do the two ends we know. As x goes to negative infinity, f of x goes to what? 0. Same thing on the other end, and we're going to talk about how this defines an asymptote real soon. But then I've got these other two ends that I need to describe, right? No, x does go to infinity. Y never goes to infinity. X, this is your x-axis. I can keep going forever to infinity. But as I do, the graph gets closer to 0 on the y. Well, now I'm going to look at these insides. I'm going to say as x approaches 0, but I need to do what? As x approaches 0 from the left, what does f of x do? Infinity, because it goes up, right? As I come in to 0 from the left, so this end is going up. Now I need to say as x approaches 0 from the right side, what does f of x do? It depends on where your asymptote is as to what you're doing. I was doing like this. I was going like left, down, right, up. You're getting x and y mixed up. Yeah. Did you really? So I shouldn't be mad at you for breaking the rules. I should be mad that no one enforced the rules for you.
So I just like x on the negative side.
Okay, no, you got to do your positive and negative always goes on. You can even do it on infinity. Well, no, you couldn't do it on infinity, but it's got to be on your value. It's got to be like this. You wrote the same thing twice.
Yeah.
That's really the same thing. You got to tell what's happening as x goes to 0. Miss McGee, what? Infinite at x equals 0. So what? Yeah. It shouldn't stop. You have an asymptote. I think that's a calculator error because there's an asymptote there, but it's still going on forever. All of these will. That's why you kind of have to know what they look like. Okay. We really should have done what we're doing today. We should have done it with yesterday's stuff. Yeah, that's pretty easy. All right, you ready? No, you're not ready because. Okay, I'll allow that. Wish I could move that one. All right, we're going to double up a little bit today because it's kind of review what we've already done. All right, so two things. The first thing, did you do green? I did too. And no sense of him coming now, he's already absent. All right, rational. Wyatt already told us that rational means fraction. Now, let's see if you remember this. Calculus did not remember this morning. I was so surprised. So let's see if you're better than them. This is the same thing as what? Square root of x. Good job, Wyatt. We're just graphing. That's all we're doing. So here's what we're going to do. We're going to take, they just couldn't remember because we had to do some algebraic manipulation and they couldn't remember though. Calculus is not really about calculus. It's just a culmination of every math you've ever done. It's so much fun. It really is. We did 2 entire problems today that each took half a page and we never had a number in either one of them. Huh? Tell me what a square root graph looks like. Oops, I need a pen. Just a shoop is all I heard. Shoop, right? It could look like that. It could be reflected either way. It could be down like this. It could be over on the other way. Yes. So tell me this. Why is it cut off that way? Why does it have a point and just goes off forever? It can't be negative. You're exactly right. You think about where this is on the graph, right? I did that really good. This x can never be negative. So there's no graph on this side because x can't be negative. But what happens if I change it to x to the 1/3? Can it be negative? Yes. So now x to the 1/3 ends up looking like this, right? So in fact, and this is the same thing as cube root of x, right? Do y'all remember the rules on going between radical form and rational exponent form? Y'all are zoning on me. Are y'all okay? Go ahead, Delaney. Tell them. What would you have to do here? Sunshine. That's exactly right. Yeah. What goes on the outside? A 4. What goes inside? Yeah, that's what I did whenever I taught you in algebra 2. You have the sunshine here. If he's in the sun here and in the shade here, it reverses when you change forms. What? What? Just butterfly it. Just butterfly it. Going back to these two. Even, odd, or neither. The one I circled in blue. I hear neither and I hear even. Justify your answer. What does even mean? And it never flips over to y because, okay? So that's going to be true if this bottom is ever even. If n is even, it's going to have no symmetry because x is going to have to be bigger than 0. It's got to be positive. Voice is good. How about the cute? Oh, sorry. Why? No, it's not. That's, yeah, I'm just telling you how to graph it, like what it looks like when you graph it. When you graph that, if the denominator is even, then your graph has no symmetry, and x has to be always be positive. Look at the graph. X always has to be positive, and it has no symmetry. So it's neat. I literally just said it, no symmetry. No, because when I said, does it have even, odd, or neither, half of y'all said even, half of you said neither, and then look at the cube root one. That one is odd. That's exactly right. And it's odd because, one, the odd number there, right? But it can be negative under. So I can have that reflected part over there, or that rotational part over there. So yep, if n is odd, it has rotational or odd symmetry. And x can be all real numbers. Anything. Yes, it can be negative. Yes. Negative, rational, yeah, all that. It can be anything. As long as that denominator is odd, it can be anything. This is X is a member of the real number set. Yeah. Just do a C with a line in the middle. We're going to definitely use our calculators on these. This is going to be the shape of everyone whose bottom is odd, and this is going to be the shape of everyone whose denominator is even, okay? Just like the others where they always look like a parabola or a cubic, just more flattened out like a pancake. Same thing with this one. So let's look at an example, and let's do some analysis on it and see what happens. Analysis. If I wanted to write this as a radical, what would it look like? No! There you go. This exponent is only hooked to the x, so be careful. Okay? If it was like this, you would do what you were saying to do. If it was like this, it would be the fifth root of 1/2 x. Different than this. All right, let's graph it. Take out your calculator. Let's see what it looks like. What do you think it's going to look like before we graph it? It's going to be a graph. It is. It's going to look just like the cubed root one. Okay? It should look just like the cubed root one for us, but let's see. It does. All right, let's do 1/2. Because I'm still dealing with just a monomial function, it's not causing as many humps and different things in there as what it could. In the monomial ones, it doesn't do a lot besides kind of stretching it out a little bit. You can put it in either way. It'll give you the same thing. Right? Well, that stretch is happening because of that 1/2. Right? Fifth and fifth, it's kind of, it's not doing anything else because there's nothing else with it. It's just a monomial. If there was what? Like under the radical? Well, let's see. Because it's old. These are old calculators. I don't know. We really use our calculators past anything basic on these. I put minus. Oh, I forgot to put. Shame. What are you asking me if? Because that's just x. It's still just x to the 1/5. What were you asking me if? Are you adding it or subtracting it or to the 1/5? Like that? Start getting into some funky graphs. No, but I'm entertaining your inquisitiveness. We're boring everybody to death right now. I thought it was interesting too. All right, here we go. So tell me, looking at this graph, what's the domain? Negative infinity to infinity, what's the range? Negative infinity to infinity as well. How about x-intercept? 0. How about y-intercept? 0. Do y'all remember how to actually calculate that if you need to? If you calculate on your calculator. That's right. Second trace 0. We're going to work with this a lot tomorrow with maxes and mins and things. Go to the left, hit enter, go to the right, hit enter, and then enter one more time, and it'll give you that point where it crosses the x-axis. It's thinking about it. Oh, come on. It's 0 for crying out loud. That's embarrassing. Thank you. Kenzie and I did our nails the other night while the boys were hunting. We made soup and did nails and watched Friends. It was a lot better than sitting in a hot deer stand getting eat up by mosquitoes. And okay, well, it will normally work. I don't know what's going on with this stupid thing. Golly. Increasing intervals. Somebody said it, negative infinity to infinity, absolutely. It's always increasing as I move. It might be just increasing ever so slightly. I could change my window and see that a little bit better. If I go from -2 to 2 on y, so I really kind of scrunch it in. You can see it a little better here. Yes. I adjusted the window there. How about symmetry? It's odd because it's an odd base root, right? Discontinuities? None. In behavior? That's right. How about the other end? That's exactly right. Maybe Charlie is the problem. What happens if I change this? Come on. Don't change it. Actually, no. Sorry. I want to get one that's got an even, but we're doing a little more to it. What's a 4? I think this is what you were asking, Wyatt. That's just to the 1/4. That's exactly right. Graph it on your calculator, see what it looks like. Looks weird. Yeah. It sounds sketch. You're asking the wrong person. So I'm no longer a monomial in this one. Do you agree? Why? It does. So I'm no longer a monomial because I have multiple pieces under here, right? So some different things start to happen. It doesn't look like a normal. I say x can't be negative, but look at that equation under here. If I put a negative in for x and I square it, what happens? It's positive. So actually, there's not going to be any restrictions on my x here, and that's why. So what happens is I end up with this piece of what looks like an even square root. But then I also end up with the other side of it because whenever I plug in a negative, the square's taking over and making it positive. So that's why it kind of comes out looking like that. You don't even have to know all that and how to do it by hand right now. I just wanted you to know why it does that. So I put it in as the fourth root. So if you hit 4 and then you go to math and choose option number 5. Yeah. I'm going to calculate that minimum right there because I want to know what that point is where it's coming in. So I'm going to go left, enter, right, enter, and let's hope it calculates on this one. It's probably just going to keep thinking. That's actually a 0. But you see the -6, the e -6, that means 0.000001. So 0, 1 is that point where it's coming in. Yeah, you always estimate that to be 0. It absolutely would. I know, I told a story. Sorry. I didn't realize I had this in here for y'all. You're going to just use your calculator, though. It's what I get for not looking ahead. It's okay. Domain, somebody said, would it just be negative infinity to infinity? And you're absolutely right. Ranges, that's exactly right. 1 to infinity, inclusive. What else do we have? X-intercept. Yes. How about Y-intercept? The brain got ahead of me there. 1. Oh, none. You are right. Great day, Stacy. Get it together. What's wrong with you today? Yes. What do I need? Increasing intervals. 0 to infinity. That's exactly right. Here's my increasing. This is my decreasing. That's exactly right. I'm sorry. How about symmetry? Even. Even. This one does have even symmetry. What am I missing? Discontinuities. None. I can draw the whole thing without lifting up my pencil, right? How about in behavior? Y'all look really bored. I'll be done after this. As x approaches infinity. Look at you, Sullivan. How about the other side? It's still going out.